Hello everyone, and welcome back to the second to last video here where we're talking about Unit 1 in AP Statistics. This video specifically, we're probably going to be talking about the most important, if not the second most important part of Unit 1, which is the normal distribution. The entire class of statistics is based on the normal distribution, and the first time you're introduced to it is here in Unit 1. And so my goal for this video is just to be able to go over some of the real basics about what you are expected to know, how do you know when it is appropriate to use, and then how do you actually use it in the context of a free response question or a multiple choice question. And so without further ado, let's dive right in to the normal distribution. Now, for this particular video here, I broke it down, like I said, into 4 separate topics. All right, what is it? Number one, when is it appropriate to use it? Essentially, how do I know when to use it? What is a z-score? Because again, that's incredibly important. And what types of applications am I going to see? How do I describe it? When is it useful? What's the wording I have to use? Things like that. So, first things first, let's talk about what is the normal distribution. The definition is something that's very simple, is that it is a symmetric, bell-shaped, unimodal distribution. That is the definition. Symmetric, obviously meaning it has symmetry. Bell-shaped, meaning it is shaped like a bell. And unimodal, meaning it has a singular peak in the middle. And so what you'll see, I'm going to draw a rough sketch here, right, of a normal curve. Pretend that that looks good, because it doesn't. Let's try that again. That's a little bit better. So it will look something like that. Now, along with the normal distribution, you also get percentiles, and something that I refer to quite often is the empirical rule. So if I take here, of this being the mean of my distribution, we've got within 1 standard deviation, right? Within 1 standard deviation, you have 68% of your data. Within 2 standard deviations, you have 95%. And within 3 standard deviations, you should have 99.7%. So if I draw these in here. On the website, I will also include a breakdown of this, because you can actually break down each individual piece based on the empirical rule. But for the purposes of this video, I'm just trying to cover the big picture basics of the normal distribution. There is a lot that we can get into here, but for right now, I'll probably dive into those in a separate video later on, under sampling distributions or something with confidence intervals similar to that. But for right now, this is a rule that's very, very helpful. Remember that these are estimates. And so the rough percentages here, if I break these down and put them on here, you have roughly 34% on each side here. It's 13.5 then between 1 and 2. This part here is 2.35. And then you have 0.15% left over outside of 3 standard deviations. So it is highly unlikely to be above 3 standard deviations or below 3 standard deviations relative to your mean. This is something that's really helpful if you recognize in a multiple choice question that you have whole numbers of standard deviations above or below, because you don't need to use the z-score formula anymore. You can jump straight to using this. Now, how do I know when it's appropriate is really, really simple. The question says it. That straightforward and that simple. If the question doesn't say that the distribution is normal, then you cannot assume that it is normal. So typically in a multiple choice question, you will see something like The one that comes to mind for me is the weights of grizzly bears follows a normal distribution. As soon as you see that, I know it's okay to use the empirical rule, to use z-scores, to use everything that comes with the normal distribution. If you don't see that wording, do not assume it, because they may be setting you up for something where the answer to the question is that we don't know whether or not it follows a normal distribution. So be warned, be careful. You need to look for that wording. There is one other time, but we will cover that in the video about sampling distributions because it's more appropriate there. Now, what is a z-score is incredibly important. The formula for a z-score is just the value minus the mean over the standard deviation. This is a huge topic that is tested both on the multiple choice and the free response. All this does is it tells you the number of standard deviations away from the mean your data point is. What else is important is that z-scores can be negative, which just means you're below the mean. They can also be positive, which, as you could imagine, means that you are above the mean. What is critical here, right? Z-scores are also correlated to percentiles. We're going to get to this in a second. But what is critical here, incredibly important, if you are asked to interpret a z-score, it is not the percentile. If you are asked to interpret a z-score, this is your interpretation. I cannot stress that enough. We're going to look at a question where you are asked to interpret a z-score. If you interpret it as the percentile, the best you can get on the question is a partial correct. The interpretation of the z-score is incredibly simple. All you have to do is make sure that your answer is put in context. That this particular person is 2.5 standard deviations taller than the average person or shorter than the average person. The context is important, but there is no need to go to a percentile unless the question asks you to do so. So let's take a look at that question and see what I'm talking about here. So here is a question. I forget what year this is from. I believe it's 2011. But it's about a strength and speed test for a professional sports team. So they give me the mean, they give me the standard deviation, and they give me the minimum. And they say, based on this, do we have reason to believe that it's a normal distribution? This is where that empirical rule that I talked about before is really important. So the first thing I'm going to do here is I'm going to calculate the z-score for the minimum. So 4.4 is my value, minus 4.6 over my standard deviation of 0.15, which is negative 0.20 over 0.15, which gives me a z-score of negative 1.33333333 forever. You can round to 2 decimal places because the z-score table that you get with your exam also goes to 2 decimal places. This should be a huge red flag. The reason being is that if this was a normal distribution, I would expect the minimum to be somewhere in the vicinity of 3 standard deviations below the mean, not 1 1/3. So the answer here is no. If this was normal, we would expect the minimum to have a z-score of about -3, but this one's only negative 1.33. Now again, if I'm answering this on the AP exam, my answer is going to go into significantly more detail than that, right? Well, actually, maybe not significantly more detail, but I'm going to expand and write full sentences. This is for the purpose of the review video. You could also go to a percentile here. I believe around negative 1.33 is going to be roughly 9% of your data. And so your minimum is in the 9th percentile here, as opposed to we would expect it to be significantly lower than that. Right? You would expect your minimum to essentially be the 1st percentile or lower. Obviously, it's not going to be perfect. But in this case, 9 to 10% of our data should be below 4.4, but it's not there. So in this particular case, we do not have evidence that this, or at least the running times here, follow a normal distribution. The second part of this question now, right, asks you about the strength. Strength is measured by the amount of weight lifted, more weight indicating a more desirable strength, blah, blah, blah. And so we have a mean and we have a standard deviation. It asks me to calculate and interpret a z-score. So again, all I do here is the same thing I did before. So for someone who can lift 370 pounds, that is 370 minus 310 over 25, which gives me 60 over 25, which gives me a z-score here of, I believe, 2.4. Now notice z-scores don't have units. The reason for that is that your numerator and denominator both have the same units, right? This is pounds, so they cancel out. This is the question where people make a big mistake and they jump to the percentile. But to interpret this z-score, all I have to say here is that this athlete is 2.4 standard deviations. And here's where the context is important. Stronger, because this is now giving my direction, right? Stronger meaning positive z-score than the average player. That is my interpretation. If you take this and you jump to the fact that they're in like the 99th percentile or whatever this ends up correlating to, the best you can get is a partial correct. Right? Now, in this particular case, it didn't actually say anything about the distribution being normal. But they did tell you to calculate and interpret a z-score. So if they're telling you to use the z-score, then obviously please do that. Now, the last part of this question is now asking you for a comparison of two people. And notice equal importance to the team in selecting a player. And who should we pick? Now, when you see a question like this of who should we pick, remember that they're scoring 200,000 plus of these exams. There is one right answer. This isn't the case of you can make an argument for either person, and if my argument is good enough, I'm going to get the points. That's not the case. So one of the most interesting things I've seen here is to use a combined z-score. So what they do is for player A and for player B, they find the z-scores for speed and they find the z-scores for weightlifting, right? So for player A for speed, they get the z-score of, 4.42 minus, I believe the average was 4.6 over 0.15, which gives me negative 0.18 over 0.15. And if I do that correctly, that is negative 1.2. And then for strength, they do the same thing. That was the z-score from before, which is 2.4. Now here's the thing. For speed, a lower z-score is better. It means you're faster. So here we can take the absolute value and say this person's total is 3.6. Right? A faster z-score or a faster person will have a more negative z-score. They will be further below the average. So in terms of speed, a negative z-score is a good thing. In terms of weightlifting, a positive z-score is a good thing. So in this particular case, again, interpreting your z-scores, context is important. If we're talking about weightlifting, you don't want to be negative. But if we're talking about speed, negative is very, very good. So now for player B, right, for their speed, we have 4.57 minus 4.6 over 0.15, which gives me a z-score of 0.2. For their strength, they're slightly stronger. 375 minus 310 over 25, which I believe gives me a z-score of 2.6. This is a negative 0.2. So for this person, their total is 2.8. So who's the winner here? Very clearly, player A is the winner in this case because they have a higher combined total z-score. This question is a very typical normal distribution question. If this shows up as your question 1, it's going to be something about using z-scores to make comparisons, because the biggest thing that z-scores do is allow you to compare apples to apples. We're now taking everyone and converting them into how far above average in your respective group are you. So I can compare data sets with different means and different standard deviations. Z-scores are the cure-all for comparisons because they level everything out to a mean of 0 and a standard deviation of 1. And so some of the calculator functions, I'm going to make a separate video on this, but the two most important ones to remember for this one are normal CDF, which this will give you a percentile from a data point. And then the last one is inverse normal, which will do the opposite. It will give you a data point from a given percentile. So those are the two most important calculator functions. Don't ever read the z-score table if you don't have to. It's got 380 numbers on it, or on one side, or something like that. It is very, very difficult, or 340 numbers on one side. It is very difficult to read, so if you can avoid it, please do. If you have a calculator that allows you to do things like this, please do. If you need to get a percentile, you do not need to justify where it came from. So if you get a z-score and they're asking you for the percentile that someone's in, you can use your calculator without any justification. So I hope that this video was helpful. Again, I'm going to make one more video after this, just explaining all of the important calculator functions that you can use in this unit. And I'll see you in the next one.